So this tutorial is about direct variation. Direct variation, think of direct variation as what we've already done, but without an intercept. So I don't know why we don't start this equation, this one first, and Edmentum's just weird. But the idea of direct variation is this idea of y equals kx. Basically, this is still our slope. So the only difference you'll see here is that there's no b. There's no y-intercept. So this idea of direct variation is this idea that the x changes the y directly. There's no like y-intercept messing everything up. So this becomes a lot easier than what we've done before. Dang, you guys are like super. Oh, I am not presenting. Thank you, Hector. That would help. Yeah, if you guys ever see me not sharing the screen and don't know what's going on, just say something. Just in general, just be like, hey, you forgot to turn on your thing again. I am recording though. So, this idea of direct variation is basically just having a slope with no intercept. So, for example, if I say y equals 4 and our x equals 2, and I say they vary directly, this direct idea of direct variation, that means that our k is equal to 2, because I'm saying that this times 2 equals 4. So that's all we're doing with direct variation. We just have a slope. We don't have an intercept. So that's all we're doing for this lesson. So like I said, this one should have been done before lines, but for some reason they decided to do it later. All right, so they're gonna test us with this idea of if something is a line or if it's not a line. So remember, a line is this idea of y equals mx plus b. So this one, it might not look like a line right away, but this is just 1/4 times x plus 7. So as long as we get this y equals mx plus b, or you guys saw the last time, remember when we were talking about the chips and the Arizonas? This one, remember we said that this was the cost of chips, and the b was the cost of, what was it, Arizonas? Because Jasmine said she liked Arizonas. So this is another form of a line. So this is the standard form. And the other one is known as the y-intercept form or slope-intercept form. Oh, and Donna, the question of the day is, what is your favorite song? So if you see people randomly talking about things, I don't know why they're talking about mango or watermelon right now, but all right. I'm either old, and that's a group, or the conversation shifted. Oh, the Arizonas. That makes more sense. So this one, we're going to say this isn't a line because, yes, it has this x plus something else, but we're not just multiplying x, we're squaring it, which is completely different than multiplying it. I know it's multiplying it by x, but you want to have a number times x. You don't want to have x times x. Otherwise, it's not a line. All right. And then in order to see if this is a line, we have to see if this is changing the same on both sides. This changes by 1, changes by 1, changes by 1. Cool. That's constant. This changes by 5, goes down by 5, goes down by 5, goes down by 5. So this is a line because it has a constant rate of change. In other words, it has the same slope. The slope is the same throughout. -5/1, -5/1. Our slope is the same, so since it has a slope, we know it's a line. This one, let's check this one out. So this one changes by 1, changes by 1, changes by 1. So they're all changing by 1. This one changes by 1, changes by 4, changes by, is that 8? 8. So this is not a line because it's 1/1, then it's 4/1, then it's 8/1. We keep doubling the change, it looks like. You guys are way too focused on your favorite Arizonas right now. And then this one should be easy. Obviously, this is a line. And this is not a line. So that's all we're looking for when we're looking for a line. We're just looking for a slope. This one, like I said, they tried to trick you. I think it was a little mean for them to do this one. So this one, like I said, it's 1/4. Dividing by 4 is the same thing as multiplying by 1/4. And the rest was just rate of change. It changed the same rate every single time. Cool. So now we're just talking about direct variation. The idea of direct variation is this idea that the variables are proportional. Whenever you see this word proportion, just think of fractions. You're portioning it out. So it's trying to say that there's some type of relationship. So if we do this y equals kx, in other words, the proportion is k is the same thing as y divided by x. That's why it's called a proportion in this case, because we're just doing division. Constant rate, that's our slope. Constant rate of change, we're talking about a slope. That makes a straight line. A slope makes a straight line because that's a rise over run. Independent variable. This is usually something we cannot control, like time. Time changes freely. We don't really control it. It just changes at the rate that it changes. Dependent variable, this changes because of the other thing. It changes because of the independent variable. Constant proportionality. This is what we're talking about by direct variation. Remember, I said that k is a constant. So k is just a slope. They keep kind of changing it a little bit, but just think of it as slope. It's a constant of proportionality. It's a slope. Same rate of change. They try to make it sound all fancy, but it's not. It's just a slope. So here we're talking about movie tickets. So we're going to talk about how the movie tickets affect based on. So if you think about it this way, money is our independent or dependent variable. What does it depend on? It depends on number of people. So the number of people affects this. So in other words, our K are independent. In other words, our K is dollars per person. That's how we figure out slope, this idea of dollars per person. Well, what's our rate of change? Well, it's how much a ticket costs per person. All right, so now we're studying direct variation, this idea that it has to start at 0. There's no y-intercept. So it's still a slope. This whole thing keeps saying the same thing I keep saying over and over again. I'm sorry, it's repeating over, sound like a broken record. Direct variation is slope. Direct variation is slope. But that's pretty much what this is, and I don't know why they keep repeating it over and over again. We already learned about lines. The only difference between a line and direct variation is a line has a different starting point. It has a B. So a direct variation is a line. So that's all we're doing here. I don't know why they keep going in major detail about this. But let's get into an actual problem as soon as this thing loads. All right. So here we have a direct variation. It starts at 0, and it looks like we go up 2 over 4. So obviously we're not going to change this because that wouldn't be a direct variation. We're going to put this right at 0 because it wants to be a direct variation. And we just need to change the slope. So if we're going to go up 2 over 4, up 2 over 4 again, what do you guys think the slope's going to be? Remember, it's rise over run. Yep, 2, exactly, Jasmine. That's good. Yeah, because well, not 2. Rise over run. You did run over rise. But that was a good guess. It's rise over run. We're going up 2 over 4. So it's not quite 2. It's more like 1/2. So make sure you guys remember it's rise over run, not run over rise. Run over rise is totally different. So that's how come this didn't work right here. This slope didn't work at 2. It's actually 1/2. Oh my gosh. And it doesn't let me do that. So you guys can even click this best fit thing and it should work, but it doesn't. So I'm just going to change this to 0.5. And we see that it's 1/2. So the 2 didn't work for the line. Well, it worked for it when we were over here, but if we go to 0.5, 0.5 is the same thing as 1/2. So that's how we get this slope. All right, so now we're going to talk about these. Let's see if these vary directly. So this is what I've been doing. It's like check for slope. You could use the formula very easily, or you can do what I do. What's happening here? I go down by 4. What's happening here? I'm going up by 2, because think of it this way. I start at -3, and then I go to -1, so I'm going up by 2, or I should say I ran 2. So I have -4 divided by a +2. What's happening here? I'm going to go down by 6, and what's happening over here is I am going up, or I'm running 3. So -6 divided by 3, that's still going to be this -2, -2. What's happening here? I'm going to go down by 2, and I'm going to run 1. -2 divided by 1, that's still -2. So that's what they're doing right here. Except they use their fancy little formula to do it. I'm not the biggest fan of the formula. I like thinking like, well, what am I doing here? If I start at 6 and I go down to 2, I just went down 4. If I started at -3 and I went to 4, I ran a +2. So that's just the idea of rise over run. Rise over run. It's going to be a big thing you guys see from now on. So let's say I wanted to do the slope here. Well, my first point is over here, this -1, -2. So it's talking about this point right here. Our other point is 2, -4. So that's this point right here. So we can use their formula, or what we can do is go here and I'm like, oh, look, I'm going down 6. And then I can go over here and I'm like, I'm going 1, 2, 3. I'm running 3. So that's that -2 that we calculated in the last problem. What they're doing here to see if it is a direct variation, they're trying to make sure that this b equals 0. So they're taking our slope that we got and they're plugging in one of these points. They decided to plug in this point. So for the y, they plugged in this. For the x, they plugged in 2. And they found out that b equals 0. So because we don't have an intercept, we can even see it from the picture. I don't know why they're doing the math for it. But we can see that because it's equal, then we can say that it varies directly. So all we're doing is we're just saying that there is no intercept. It's gonna touch 0, 0. Is everybody kind of understanding the difference between direct variation and a line? Anybody not understand the difference? Cool. And that's literally the difference. Why do they use an M and why do they use a K? I don't know. Somebody started using these and they just stuck. So K is just this idea that there isn't going to be a B. M is a slope. If there is a B, it doesn't matter. Which one of these correspond directly? Well, I like the fact that this one has a 0, 0, but we have to see if it makes sense. So if I do 1 times 5, so what I'm doing here is I'm doing k x, and I'm seeing if I get a y. So if I plug in 1, if I do this, what I'm saying is k times 1 equals 5. So I'm saying here that my k is 5. That one's a little confusing. Let me see if I can word it better. Remember how I said that y equals kx? Another way of saying it is k is equal to y divided by x. So if I do y divided by x, I get 5. So hopefully that made more sense than that other thing I did. So let's try this out. If I do -1 times 5, I should get -5. But according to this, I'm getting a 3. These aren't the same, so I know this can't be right. Direct variation means you have to multiply directly. Okay. And this one doesn't make any sense because, like I said before, it should be multiplication. And for some reason, it still has this point right here. So this one can't be right either. All right. Well, let's look at this one. So if I'm looking at this point, let me erase the rest. If I'm looking at this point, I'm saying that y is 6 and my x is 6. So my k should be 1. Well, 4 times k does not equal 3. What I'm doing is I'm doing this, and I'm trying to see if it equals that. It doesn't equal that. So this isn't direct variation either. This one makes sense because what's happening here is it's being multiplied by -1. My y is 1. My x is -1. I end up getting -1. 4 times -1 is +4. 3 times -1 is -3. That's the only one that makes sense. That's the only one that fits this pattern. So that's a big difference in direct variation as well, is if we have these 3 points, it's easier to see if they're on the same line because we don't have to solve for the intercept. We could do what they did as well. They found the slope and just saw if it worked. That's what I was doing earlier when I was doing this whole like k x equals y, and then I figured out what my k is, and then I just multiply k by my x. Everybody getting this so far? Anybody have any questions on how I did all of that? Everyone good? Everyone awake? I'm going to start asking you guys like random wake up questions or just say something shocking in the middle of class. All right, so let's see if we can determine direct variation. So if we're determining direct variation for this one, we're trying to see if the slopes are the same. So what we can do is we find the slope. We get this, we get 10. This is a 2. That means we're trying to multiply. So we're doing y over this. So just remember, slope is always, or k is your y over x. If it very directly, this should always be true. You should always be able to do, let me do 35 divided by 7 and get the same answer as your slope. So if you're doing this over and over again, they're doing slope. I'm like, if it varies directly, it should always be true. If you do 35 divided by negative 7, you should get negative 5. If you do 25 divided by negative 5, you should still get negative 5. They're doing a lot of work for no reason. If they're proving that this is true, direct variation means it's always equal. You should always be able to do y divided by x and get the same answer over and over and over and over again. So that's all we're doing here. Direct variation is so much easier because you don't have to worry about a random b. So if it is direct variation, just divide. Same thing with these. I don't know why they're making this so complicated. If you do negative 6 divided by negative 8, you end up getting 3 over 4. Well, guess what? If you do negative 3 divided by negative 4, you end up getting 3 over 4 also. If you do 9 divided by 12, you can reduce that to 3 over 4. So direct variation, if you take the y divided by the x, it should be the same every single time. So ordered pairs, you can do that the same way you do the table of values. A graph, I think, is the easiest because if you connect them, graphs are the easiest because if you connect them, it's a straight line and it cuts through the origin, cuts through the 0, 0. And you can see that here because they know how to draw a line, and I don't know how to draw a line. So trust theirs more than mine because they can draw and I can't. That was a little better. All right. So moving on to this one. If this is direct variation, so if it's direct variation, I should be able to take my y divided by my x, and I get positive 2 because these cancel out. And if I get 4 divided by 2, I also get 2. And if I get 6 divided by 3, I also get 2. So my answer for this one should be 2. You can also do it by doing the slope, but that one I think is weird because if I do this, I get 6 and 3. So 6 divided by 3 is also 2. If I go like this, I get 2, and this is 1, and 2 divided by 1 is also 2. So doing the slope does work, but if you're trying to prove it is direct variation, just do y divided by x a couple of times. If you do your y divided by an x a couple of times, it just makes it so much easier. Now let's see if this is a direct variation. So if I do this, in theory, I should be able to connect these lines. So if I do this, I'm going down 3 over 1. I go down 3 over 1. Oh, down 3 over 1. So right off the back there, I see that it does have a slope down 3 over 1, but it doesn't touch the origin. So remember, 0, 0 is the origin. So if we're doing that, also I keep forgetting to mention this, guys. it's really hard to kind of do the work and pay attention. So what I usually recommend is take your notes. If you can do it, then great on you. But if you're having trouble, I recommend just taking notes. Figure out what slide we're on, taking any notes that you see. All right, now we're going to do direct variation. So if this is direct variation, I'm going to do y divided by x, and they should all be the same. So -3 divided by -2, that's just 3 divided by 2. And if I do 3 divided by 2, well, obviously it's the same. And if I do 6 divided by 4, it doesn't look like it. But if we divide the top and the bottom by 2, we still get 3 over 2. So this means it is very directly. So if it is very directly, our thing should be 3 over 2. This is making sense to everybody. Basically, direct variation should always just be y over x. This is a lot different than when we did a line, because if we did a line, there's a bunch of weird stuff here. Because if we do a line, we're going to end up having this y take away b divided by x. So this is how come this is not direct variation. There's something else besides that y in that formula. And if you guys don't understand what I did, is I just got m by itself. I subtracted the b from y and then I divided by x. All right, let's see what we have here. So now we're going to do real world problems with direct variation. The easiest real world problem, I think, is when you're working. So working. So that's where we get these dollars per hour. Guess what? If you don't work, you get no money. If you work 1 hour, you only get whatever you got there. I mean, there's taxes and stuff too, but we can save that for a personal finance class. So this is this idea. He earns money raking leaves. So he earns $20 for each yard. So then he's getting this $20 for every yard. This is his direct variation. How much money is he getting? It depends on the number of yards. So in other words, X is yards because the money he gets is based on that. So Y equals that. I don't know why I put dollar signs as equals. So Y equals the dollars. Our independent variable is how many yards he has. He can't really control. He has some control. I mean, if he decides to be lazy and not go to work, then obviously he's not going to get any money. So this is direct variation because if he doesn't do any work, obviously he gets no money. So let's see here. So this one is similar to my example of the dollars per hour, but you can see here that 0 divided by 0, well, that's 0. So that's how come we never really include the origin when we're doing this. Don't ever do 0 divided by 0. It's going to throw you off. Do it when we actually have numbers. So if I do 20 over 1, that's the same thing as 40 over 2. You still get that 20. Or if you did the slope, you went up by 20, you went up by 1, 20 over 1. Same thing. Slope and direct variation are the same thing. I just think it's so much easier to just do y over x. And it's the same thing because guess what? What's the change in y? Well, the change in y is going to be 20. What's the change in x? Well, it's only one more yard, so it's 1. So that's where we get this 20 over 1. Change in y over the change in x. This triangle that I keep doing, it represents delta. It's the change in y. How do we figure out the change in y? We take one of the y's and subtract the older y. That's it. But instead of using that formula, like I said, it's easier to just do y divided by x for direct variation. So here we can see the direct variation. It's a straight line. If it doesn't work, no money. Like I said, I'm going to sound like a broken record for this class, but hopefully that just makes you guys understand it that much better. So here our k is this 20, which is also our slope. And we can even use it to predict. So if he wants to get $100, how many yards does he have to do? Well, we can plug in 100, and then after we divide by 20, it's like, oh, cool. If we do 5 yards, we get $100, which is what it says here. So now let's do a real life problem. So let's go to the movie theater. So if we're going to the movie theater and it's saying that there's a rate of 3 tickets for $20, that's saying that the dollars, so this was way back in the beginning when we did our introduction, our dollars is 20 and the number of people going is 3 because you only need 1 ticket per person. So that's where we get this 20 over 3. That's our direct variation. Our prices change based on how many people are going. So if 6 people go, guess what? So if 20 over 3 is equal to 6 people going, guess what? That means we have to do 40 over 6 because 40 over 6 is the same thing as 20 over 3. I just doubled the amount of people that are going, so I have to double how much it's going to cost me. That's what it means by having direct variation. If you double one thing, the other thing should also double. Let's take a look at this one. So what's the formula? Well, we already figured out our slope. So our slope and our direct variation is the same thing. So we're going to do this again. Simple. Nice and easy. We're just plugging in our relationship. They call it proportionality. I just call it the slope. So that's all we're doing. So, okay, I'm glad it's helping you guys understand, at least. So let's think about it this way. I already said, like, oh, guess what? If we double the people going, we're going to double the price. Oops, that was my bad. So I doubled this. I multiplied this by 2. That means I have to multiply this by 2. It's the beauty of direct variation. Well, if I multiply this by 4, that means I have to multiply this by 4. Does anyone have a calculator on them? What's 4 times 40? Or is anyone just good at multiplication? 160. Yep. So that makes sense because guess what? If I do 20 over 3 times 24, this is why I like doing it this way, the times 4, because this is weird. I have to do 480 divided by 3. I'm just multiplying first, or if I divide first, I do 20 times 8. But I like to get it this way. I multiplied by 4. That means this I should multiply by 4. All right. Well, if I look at this, if I multiply this by 10, because it's direct variation, this is what makes direct variation nice and easy. I'm going to pick this one. I'm just going to multiply by 10. So does anyone want to take a guess at how many people go? I looked over and I saw Jasmine's last answer, and I'm like, no, it's not 160 people. How many people are going? I'm multiplying 40 by 10 and I get 400. So how many people are going to go? Yeah, 60. I'm just taking the 6 times it by 10 and I get this 60. Another way of doing it is this idea of like if we have 20 over 3 and we get this 40 over who knows what. I know we know it's 60, but what I'm going to do here is I'm like, oh, cool. If I multiply this by 20, I can multiply the bottom by 20 and still get this 60 because I'm following the slope. And they're doing it by just plugging in the x or the y. So if you plug in the x or the y, that still works. Let's take a look here. So my first point is going to be at 0, 0. Where's my next point going to be? Remember, it's every 3 people is $20. So does anyone want to take a guess? Say the number of people first and then say the number of dollars. So what are we doing here? How many people are going for the first ticket? 3. All right. And how much money is it for 3 people? Not 60. 60 was if 3 groups of 3 people went. That's 90. So I kind of get what you were saying there, Alyssa. um, yeah, if 9 people go, if 3 groups of 3 go, it would be 60. um, I don't know. I think your 2 is pretty far away from your 6, Alyssa. Yeah, it's 20. So yeah. So we're not doing the third one down. We're not doing 9 people going to get that 60. So if 3 people go, we're paying 20. And because it's direct variation, we can just do a little line there. Oh shoot, Hector, I'm sorry, I didn't see that. I was just too distracted by Alyssa going like my finger slipped. It hit a 6 instead of a 2. I did say I was going to make fun of Alyssa this class, right? Or was that supposed to be last class? Well, I'm making fun of her this class. All right. So what's happening here? What's happening here is we're trying to figure out what's going on. So it's $20 is 3 people. So if we're doing 45, we're getting this 360. I left the answer here because this is quite a bit of work, but it lets me just scroll here and kind of explain it. What they're doing here is they're multiplying the 20 and the 540. Another thing you can do is you can do this divided by 3. 3 goes into 5 one time. 3 goes into 24 18 times. And then multiply that by 20, whichever way works best for you. So and then from there you can divide it. A lot of people like just multiplying first. It's just so much easier to just say, I'm just going to multiply first. I know that y equals 20 over 3, and I know that my x, the number of people that are going, is 54. Let me just multiply the top numbers together and multiply the bottom numbers together, and then I can just divide afterward. So you guys can just use a calculator, but be careful. Don't let your finger slip like Alyssa's did. She hit, I don't know how she hit a 6 instead of a 2. That's weird. You should get your keyboard checked out, Alyssa. I don't want to check out my rate my professor after today. I actually don't have one, but please don't make one for me. I'm not gonna like looking at that if you guys do. All right. So do your self-evaluation. Write down any problems you had. So Alyssa had trouble with keyboard. Wow, you guys are gonna make fun of me next? I feel that's like every class. I'm surprised there wasn't a boomer joke when you guys were doing your favorite songs. All right. So basically, I said it like a million times. slope is direct variation. It's just a special type of direct variation. Special in the sense that all we have to do to figure it out is y divided by x. That's what makes it so special. All right, let me stop the recording. I keep doing that. And I'm going to